Hey, good evening, everybody. Thanks to Ryan Toomey's there for the photos. We can always use viewer media, videos and photos, so definitely send those along if you have something that's interesting weather-wise. Or on a slow night, we'll just pretty much take anything here, to tell you the truth. All right, let's see what it looks like outside here right now. Pull up the outside cam and take a look here. And it's yeah, it's dark, as George Carlin would say, and you can see Jupiter twinkling up in the sky right there. That's it, hanging low, and see some other star. And let me see if I can figure out what that is. I've seen that last night in the sky too, and I know you all can also see that star if you go outside. So let me see if I can ID that real quick here. I have a little star chart on my iPad, and it's coming up right now. And let's see. You know, I would have to probably go out and check this, because I think that could be Arcturus and that could be Jupiter, because Jupiter is pretty low on the horizon right now. So, actually, no. Yeah, there was something out there. Pi Hydra? I don't know. Okay. I'll have to go out with the program and figure that out later. So let's just go on with the charts. And let's see here. Start with the basics, and I think we'll head out into the Atlantic. Since things are getting active, Jose is still out there, and at this time, Category 1 storm, 983 millibars, 65 knot winds there, and we've got a couple of other systems of interest. 80% chance of formation here. This is off your screen. There it is. That's going to be in that little box of concern right there, because that could easily take this out into the Caribbean. And the Caribbean is an excellent track for taking it up into the Gulf. Sometimes it will go into Central America, of course. But depending on the pattern, that could be of a lot of concern here. And then Tropical Depression 14 is active now, 30 knots. And that's got some recurvature there, but that could mean a similar system for the other, similar track for the other system like that. So we'll just see what the GFS has there. Okay, we can see the systems out there in the Atlantic, and a lot of these are being spawned by these Cape Verde systems, easterly waves, and thunderstorm clusters, and there's one right there. That's going to be on its way westward, and that may become a factor in about another week. And from what I've seen of satellite loops, a lot of these waves get generated out here in Sudan and Kenya, and those get picked up by the flow around the high pressure out in the Sahara, and they carry eastward into the tropics there. So anyway, that's where systems are coming from, and Jose, Category 1 storm. And then out here in our neck of the woods, we've got a very cloudy pattern here, a lot of cumulus. And I think we've got kind of a cold upper level trough there, keeping things kind of unstable. And wow, look at that out in Montana. We've got a pretty well-developed baroclinic system in place, so we'll be looking for that on the charts. And then we've got a lot of fires, looks like still going out in the Cascades there. Okay, so that pretty much completes things. Let me take a look at chat right there. We got Alex Front and Ron Chalfant. Ron Chalfant in Southern California right there, as a matter of fact. Let's see. I believe he is located in think in these mountains here. I don't know if you can go out and wave and say hi, maybe we can pick you up. Anyway, I think that's Big Bear right there, and I don't know, he's somewhere out in this area, north or west of San Bernardino. And wow, look how cloudy it is in the LA basin right there, and how clear it is offshore. Normally, this is not really a pattern that we see, so we'll take a look at the charts. This has the look of a, I don't know, it's got kind of a look of an onshore flow, but I'm not 100% sure. It's very strange. But we'll look at the charts, and maybe I can do that right now. Looks like we have a pretty strong low pressure system in the southwest deserts. Looks like kind of like a heat low, and then the gradient is coming in from the northwest. Okay, so maybe it is a little bit of moisture driven in. We'll have to bring up digital atmosphere and look at the plots for that. And I'll pull up the, this is one thing you can do in digital atmosphere. You can pull up older data. So we'll look at data for earlier this afternoon when the image was taken. I messed that up, didn't I? Okay, download, retrieve data. We want to go to earlier today, not tomorrow. So this will give us a bunch of data to look at. All right, so we're analyzing that, and we'll take that out west. And yeah, looks like we have kind of a westerly flow there in the LA region. And looks kind of cold actually up in Nevada. Look at that. These are going to be early afternoon temperatures in the upper 50s and lower 60s there in the high deserts of Nevada. And we've got that northerly flow back here. So it looks like we've had a frontal passage. So that's what distinguishes this from the usual heat low and the Pacific high out here. This is going to be more polar in origin, so we're going to be looking for a front, maybe something like that right there. And I'm kind of curious whether we can bring up this front using the theta analysis. Let me see if I can do that. Thin the data out a little bit. Okay, and I'm going to go to theta. And this is way too smooth to be using, so we're going to have to bring that analysis down a little bit. Knowing the basics of smoothing there is very essential, and it's kind of hard to tell because this is very normal. You're always going to see a theta gradient near ocean surfaces, and that kind of messes up the fields. But I do see a gradient out in the Rockies here, so that's of interest. There's probably a front, maybe something like that right there. Looks like a little bit of bad data in northern Nevada, but there is a gradient through that area. And then I think that's probably carrying through the LA basin, something like that. So that's kind of what I'm seeing here in the theta E field, or the theta field. Let's go a little bit westward or eastward. And we'll bring up the plots for the eastern U.S. And it looks like actually we got a little bit of southerly flow coming back. So actually I was about 180 degrees out from what I was seeing in the surface field there. But the flow is starting to turn around there. Looks like high pressure dominating things around Cincinnati, the Ohio Valley, and then we've got the Bermuda High feeding around the south side of that high, kind of like that right there. Up to the north, there's the front coming through Minnesota and South Dakota. And it looks like we just have kind of an abundance of moisture out in the Tennessee and Kentucky area. In Texas itself, it is heating back up again with that southerly flow in place. Sorry, guys. Oh, good grief. Yeah, sorry. I had this outside camera view set up, and that really messed things up. I'm sorry about that. We'll just kind of keep going here. I think you were able to see most of that. So that's the pattern there in the eastern U.S., just southerly flow through the Midwest. And the front looks like it is up through Minnesota, Lake Superior, and down to Nebraska like that. All right, let's see here. Let's go into some of the charts. Got a marginal risk up in South Dakota, Minnesota, and Nebraska. That's probably due to that front that's coming southward out of that area. And then we'll look at the 250 millibar chart from the Canadian Met Agency. And this is showing that the polar front jet is still way up in Canada. However, there is a branch of it coming through California up into the Dakotas like that. And that is actually going to support that front for sure through the desert southwest. Typically, we find that from the trough to the downstream ridge. So a good location for that front is going to be something like that. And we're kind of close to that right now, but we would go through the process of analyzing the surface chart and resolving that to the upper air chart and so on. Let me see if I can bring up the California data one more time, because I know that looked pretty bad earlier. Okay, so there's the picture from California to Colorado in the Great Plains. And there we see that northerly front through Nevada. And then around in the coastal regions, we have that westerly flow and that banked up moisture, indicating the front passing through that area there. And it looks like even though we have southerly flow in Cedar City, temperatures there are pretty cold. The data kind of supports the front being a little bit further south. So I think we could be looking at something like this here. And the other thing that we would look at, and I'm not going to do that since we don't have the time for this, but I would go individually to each station, maybe pick out a few favorites, and I would go to aviation weather. There's a METAR resource there on aviationweather.gov, and that's going to be way down here under this request METAR data. So, for example, I might want to go and look at Cedar City, Utah, and I can look at the past 24 hours. And what I would look for is changes in the data over time. So going from older data up to newer data, I would look for anything kind of unusual. And that's a very effective way of finding changes in the air mass. And right away I can see we go from southerly flow, southwesterly flow, and right around here, about 8 in the morning, we go to a northeasterly flow and a northerly flow. So that represents a change in the air mass, even though they have southerly winds there that we're seeing. Yeah, one of these stations had southerly winds. Might have been another site there in southwest Utah. But we're clearly showing that in southwest Utah. We've had the front come through this morning and shifted things around. So for frontal placement, we're going to bring it south of Cedar City. So there's probably some local phenomenon going on in this area to give you that southerly wind, and you have to kind of be on guard for that. Once we realize that the air mass did go through that region, then we get kind of a much different picture of what the map looks like through Utah. So front definitely did pass through, and Las Vegas is kind of another area that's in question. I'm not sure if the front passed through there or not because they are showing that south wind. So what we do is we look at the trend data. And we start at the bottom, and we can see very consistent southerly flow. And then things go northwesterly right here, about 15Z. And then they go kind of variable. And the other thing I would look at is pressure. We go from 2970, 71, 72. Then it spikes up to 2980. And that could be the morning pressure tides. Those kind of kick in about 10 to 11 in the morning. But the pressures stay kind of elevated. And I would also compare this to yesterday's data. If we're showing that yesterday was a lot warmer than 90 degrees, then I would have good reason for suspecting frontal passage. And it looks like yesterday they were up to 90. Pressures were a little bit lower. So they could have the front right on top of them, because I'm not seeing that really stout south wind in place there. So that's kind of like the thinking process you would go through analyzing data in that area. Give me just a minute, and I'll let you look at the satellite data. And I'm going to go grab something, and I'll be back here in just a second. I'll give you guys a loop there. Okay, be back in just a minute. Okay. Yeah, I'm back there. That was just kind of a quick break there for some water and nasal decongestant. Okay, let me take a look at chat. We got Justin Pulliam here and David Holcomb. Alex Front in a very calm, mild pattern. We have Fun with Tech here, and Sue M in Indiana. Megan John up in Minnesota there with 73 degrees and storms brewing. Carl likes the video. Oh yeah, the satellite presentation of the hurricanes. If you guys haven't seen that, take a look at the video that I posted about 8 hours ago. I worked on that last night, and I pulled together a whole lot of satellite data showing the development of Harvey and Irma. And it's very interesting stuff. It uses pretty much all the conventional GOES imaging to like every single frame that's not on GOES 16 but on the other satellites to put that together. And I don't know of a source for the ABI data for GOES 16. If anybody knows how to get that on McGuidus, feel free to let me know. Okay, Ryan Toomey's, thank you for that those opening pictures. VOJO 77 in Illinois. The iPhone has an amazing stellar overlay. Carl uses Stellarium. Alex Front has a telescope in the garage. Yeah, I've got a 10-inch Dob I'll probably show you guys that sometime. It's sitting together. It's sitting gathering dust right now. But I'll get that out as things cool down. Okay, SUEMS reports lots of buffering. Lots of buffering. I've got all green here, so I'm not. Let me think what might be using bandwidth here. Make sure I'm not streaming at 720. Let's see here. Let me know if you guys are still seeing buffering. Yeah, I can't find anything unless maybe one of my devices is updating. It could be something like that. Hopefully one of these days we'll get a better internet connection. Veo Joe says he was the camera operator for webcasts. Yeah, I used to do TV weather for about 2 years, and I kind of miss that. It was definitely a lot of fun. Carl Berghoff reports 86 in Wisconsin, 69-degree dew point. And let me just scroll through the rest of this. Let's see here. Carl Berghoff says record high was 96 for Wisconsin today, set in 1937, and that's referring to an old record. Okay, no buffering. That's good to hear. Okay. Yeah, CPU issues. I think it might have been that outside camera window, that thing that I was using earlier. Maybe that was doing something bad. But we're back to the normal view there, so I think we're good to go. Okay, so you guys probably got to look at Jose there. Category 1 storm spinning around out there northeast of Bermuda. Looks like that's heading to the west, but that'll be recurving here very, very soon. Still got a mass of storms out there in the Gulf of Mexico. Doesn't appear to be doing very much. I know that the west part of the Gulf is kind of cold right now. The east part of the Gulf, I think, from what I remember last night, that will support hurricanes. However, these storms here, they look a little bit sheared there, and that may be why we're not getting development of that into a hurricane. Got a massive moisture crossing the Mexican Rockies. Looks to be like we've got a very stout west-southwest flow there associated with that jet there in the desert southwest. And then taking a look up north, there's that frontal system up in the Dakotas. And it's definitely got the look of lots of warm air advection in this area here. So we'd probably be looking at a warm front somewhere in this area here, or just a lot of overrunning. And then out here in this region, we've probably got cold air advection working through that area. And then out in the Great Plains, a little bit of mid-level clouds there, maybe some elevated showers. And then out in the northeast U.S., things do look cold. In fact, I can show you a neat trick we can do here with the GOES infrared data. Let me size this. What you want to do is look at the bottom of the window. And when I set this cursor on New York, I'm going to have to go down even. Yeah, let me do this here. Yeah, okay, it's in the bottom right. It appears over here. So check that out. When I set the cursor on New York, we're reading out 290 to 291 degrees. So we're getting a direct readout of temperature. 291 degrees Kelvin, that's going to be about 17 Celsius, which is about 63 Fahrenheit. So does that correspond to the current weather? Should be fairly close. It is a reading of the surface and not the air mass. We have to kind of keep that in mind there. But let's take a look at the plot for Albany there. And we can see that, yeah, there are some 60, they're a little bit warmer there. 68 instead of 63, but that does kind of get us on the ballpark there. And then if we go to these clouds here in West Virginia, much colder, 277 Kelvin, which is about 4 Celsius, about 39 Fahrenheit. So these are obviously going to be colder cloud tops. The air mass in West Virginia showing 60s, 68 Fahrenheit. So we know that that layer there, 4 Celsius there, that's going to be mid-level clouds or low clouds, probably like about 5,000 or 6,000 feet. And if we really want to know, we have to be able to know how to identify the heights. And what we do is we go to the SCUTs, and we'll just bring up a SCUT in the area like Roanoke. And if we look for 4 Celsius, that's going to be about right in here. So that'll be somewhere between about 8,000 feet and 13,000 feet. So chances are what we're seeing there is altocumulus. Little altocumulus layer, a little bit of mid-level cloud there in West Virginia and southern Ohio. There's a look at the water vapor imagery. And we can see a little bit of that dry air there in the western Gulf. Thunderstorms there, a lot of moisture associated with those, a lot of mid-level moisture. In fact, looks like kind of a band all the way up into the Carolinas and Georgia. And associated with that band right there, quite a bit of shower activity. And this is all south of that high pressure area there in New York. It doesn't appear that the Bermuda High is... Yeah, it kind of looks like this high pressure area that we got here is kind of a combination of polar high up in the northeast U.S. and a combination of the Bermuda High itself. Because we don't quite have that really deep southwesterly flow there in New York and Ohio. We've got instead of kind of like high pressure there in the Ohio Valley. But once that disappears and sinks southeastward into the Bermuda High, then we should see some pretty deep southerly flow across the eastern U.S. there. So let's go ahead and head into the forecast and kind of put things together. I guess we can look at the upper air pattern and see what that's telling us. Pretty good troughing out there in the western U.S., so that's going to be the core of the... It's going to be close to the core of the polar air mass over Idaho there. And that's going to lift northeastward, and with it, some sort of frontal system moving up to the Dakotas on Saturday, tomorrow. Looks like chances for rain in northern Minnesota and western Ontario there, maybe Winnipeg. And then for Sunday, when we do the webcast on that date, that wave is pretty much gone to the north, and we've got a little bit more troughing coming in from the west. Subtropical jet very active across the Texas Panhandle. That may help to get a few storms going there in West Texas. Then for the webcast on Monday, very active subtropical jet across Texas and Oklahoma. Polar front jet well to the north. Looks like a new push of cold air there in the Pacific Northwest. Then going into Tuesday and Wednesday, flow really increasing up to 120 knots there in Oregon, Idaho, and Wyoming. And that moves quickly up into the Dakotas on Thursday and Friday. And then we get some very deep troughing there in Nevada and California, so things should be very active throughout pretty much all of California. Then by Friday morning here on the 22nd, things moving into the Four Corners area. So this is kind of suggesting a frontal system kind of like that right there. And very likely we'll see this emerging out into the Great Plains, and with that, the development of thunderstorms. Because with this very strong westerly component, we should see quite a bit of lee-side troughing, and that should bring a whole lot of moisture up from the Gulf. That, with the strong bulk shears aloft, will help get thunderstorms going pretty easily. And with that, differential advection and actually just the advection of cold air itself westward, that's going to mean destabilization of the air mass. And then things will kind of shift eastward into the Great Lakes area for Monday. Cold air coming into the Great Plains and central U.S. on Monday. And then we get into kind of a northwesterly flow. Then that's going to be kind of a cold pattern for much of the central and east U.S. for the last several days of September there. Okay, so we can kind of use the upper air patterns. We've already got a pretty good idea what's coming. And what I'm kind of wondering about now is where that hurricane we were looking at is supposed to make landfall. Not this one. This is Jose. That's not going to affect us. So anyway, a little bit of cold air coming southward there for Sunday. So there's the front on Monday through Kansas and Iowa. Jose on its way north there. And looks like we're under the influence of mainly this old stagnating polar high over Iowa. So what we've got here is southerly flow in Texas, but that looks like kind of a recirculated southerly flow, kind of like that. Then for Monday the 18th and Tuesday the 19th, actually it looks like we do see Jose scraping Cape Cod. We talked about that possibility a few days ago. So it looks like that may actually happen, and there's probably enough uncertainty here at 108 hours where it could even come up into New York, so we'll just have to see. Could go exactly as planned, or it could go even further eastward. Strong front up through the central U.S. There's that warm front up in Ontario Wednesday, and snow in the higher elevations there of Montana and Alberta. Very strong southerly flow in Texas. And the main push of that cold air will be to the northeast. However, you can see it laying down this cold, this frontal boundary right here. So the actual front will be located something like this. And that's going to be for Thursday the 21st. So this is the front starting to come out of the Rockies and things becoming very active. Cyclogenesis there in Colorado, and there's our thunderstorms developing on Friday evening in western Canada. Very strong southerly flow in Texas, Oklahoma, and Kansas. And you see those storms light up overnight. And here comes our hurricane there into the waters just off the Carolinas. A few days ago, the model was trying to bring landfall into Florida. Now it looks like it's going for some sort of recurvature, maybe with the approach of this trough here. Very strong westerly winds out in advance of it. Tropospheric westerly flow would be lifting that hurricane up to the north. So the main track up into the Cape Cod area, but with Irma, this was the original track. It had Irma coming up into the Chesapeake Bay area. And we know what happened with Irma. It ended up coming into Florida. And that's because there's so much uncertainty in the Caribbean. We've got a ways to go with this path. And let me show you what I mean here. Look at the 5-day outlook here. And you can see that with this system here, I'm not sure which system it is that's coming up into the Carolinas area, but these storms are going to be, these systems are going to be moving across the Windward Islands, the Leeward Islands, and Dominican Republic and Cuba over a period of days. And all it takes is a little bit of a southward deviation to get different results as it approaches the coast. And that's kind of what happened there with Irma. It went just a little bit more south than forecast, and that brought it into Cuba there. Okay, let me get things straight with which system is being brought into the West Coast area. So let me bring that up. GFS. I guess I'll try the Atlantic plot. I wish we had something nice and wide covering the Atlantic basin. That would be really helpful. Because starting out this loop, I don't see where that hurricane is. But I'll just kind of run these through and see if I can find it. Yeah, it looks like something comes together here at about the, this is the 38-hour point here. That's going to be just east of the Windward Islands. And that crosses, I guess, around Dominica. Just south of Puerto Rico, 946. And then down to 938, that's going to be probably a Cat 3 to Cat 4. Dominican Republic breaks it up there. A lot of weakening to 980. And then we see it kind of arc northward, regain strength down to 934. Another strong hurricane there. So the track is something like that. And I think that is pointing to, yeah, that's going to be this system here that is heading up towards Puerto Rico and the Dominican Republic. So there's still enough uncertainty. We don't know exactly where the track is going to be once it gets to be 5 to 6 days out. That's just beyond the range of the models there to accurately forecast. So, of course, we'll just watch it, and hopefully in the next 3 or 4 days we'll have a much better picture of where things will be headed. Now, one way we can look at the uncertainty is to look at the global ensemble forecast model. And these are possible solutions. So to get up to that hurricane landing point, we have to go up to 234 hours. And we have, like at the top left there, we've got Ensemble 1, which brings it up into the Chesapeake Bay area. And this is basically the normal GFS run at a lower resolution, many different times with different starting conditions. We've got lots of recurvature on this model. Another one grazes the east coast. Another one brings it up into Cape Cod, grazing the Cape Cod area. Another one goes very fast with the hurricane, brings it up into the Cape Cod area. And then just let me run through these very quickly and see what I'm looking at. We've got a couple of them coming across Florida there. There's one right there, ensemble number 9. Another one kind of stalls it out over North Carolina, number 10. Kind of sits there for a couple of days and then moves northeast. And then looking at the other ensembles, let's see here. So we're looking at the hurricane with different ensembles. Okay, number 11, very strong recurvature. Number 12, extremely strong recurvature, barely even appears. Number 13 brings it into the Carolinas. 14 into Chesapeake Bay. Number 15, very weak into the Carolinas. 16, kind of strong into the Cape Hatteras area. Number 17, into the Carolinas. Number 18, into the Cape Hatteras area. Number 19, Carolinas. And number 20, the Carolinas. Okay, so you can kind of get a pattern here. We've got a lot of the GFS looking for a possible solution into the Carolinas there for that's going to be the 276-hour point. So that's still a long ways off, but that kind of shows you that there's an array of different possible outcomes rather than this one on the regular GFS where it passes Cape Cod there. So this kind of shows you, then we did get that westward drift there with the with Hurricane Irma. So we'll just kind of have to keep a watch there on the East Coast. And we'll see what happens there. Okay, so that's about all I got for tonight. And I'm just reading the comments here. Carl Burkhoff says a good intro to dynamic meteorology is by James R. Holton. And if that's the book I'm thinking of, I think, yeah, that is a pretty good book there. One of my favorites a long time ago was, when I was getting started, it was a book by Stanley David Getzelman. And he was, I think he worked for the State University of New York. And he had a very accessible intro into intermediate meteorology. And this was around 1980 when that book came out, and it had a lot of humor in it, which was kind of unusual for that time. Books were really dry on meteorology back in those days, so that was kind of refreshing, and it kind of influenced how I did my books later on. So see if you can find that in used bookstores or on Amazon. Stanley David Getzelman. He's got some good weather books, still relevant today and worth checking out. I think the name of the book, the specific one I'm talking about, is something like The Science and Wonder of the Atmosphere. And it's a big, thick, hardcover book. Sue M says we can't predict hurricane tracks 6 days out, but we know Earth temperature 100 years from now. Andrew says CO2 is a greenhouse gas, but predicting climate is hard. Andrew says, good night, Tim. Excellent as always. I appreciate it. Brian and Carl there saying thanks, Tim. And yeah, all right, very good. Well, I hope you enjoy the webcast, and we will be back tomorrow. and we'll just do it again. So thanks for joining, and we'll see you tomorrow.